Welcome back. Today we're going to talk about modeling and equation solving. And part of the hard part about teaching and learning this is to teach your strategies is important. And teaching strategies is not like teaching an algorithm. So it's not teaching quadratic formula or completing the square. And so the strategies that we're going to talk about here, one strategy for problem A may not work for problem B. And so you kind of have to be flexible. And the thing about problem solving that's challenging is you have to look for similarities in problems, but they're all going to be different. And so what I'm going to try to do is try to go through and give you some strategies for looking at these problems to try to solve them as you go along. Okay? So here we go. Here's one you could probably imagine what this predicament. You're standing in a pizza parlor, right? A pizzeria sells a rectangular 20-inch by 22-inch pizza for the same price as its large round pizza, 24 inches in diameter. If both pizzas are the same thickness, which one offers the most pizza for the money? Okay, so this could be a potential problem for me. I want the most pizza for my money. And so what I do is, I do this at the grocery store too. Well, how do I get the most for my money? So is my price per ounce or per inch or per foot, whatever it happens to be, where do I get my most for my money or my least amount of price for the money? Okay, so we need to work on two separate things here. The first one's going to be the rectangular pizza, and then the one over here is the round pizza. And if we figure out the square footage of the pizza, or how many square inches are in the pizza, they're the same thickness, okay, so the volume is the same. If we figure out which one has the most pizza for the money, then that's going to be our better deal. So for this one, so 20 by 22 is equal to 440 inches squared. Okay, 440 inches squared is our amount of pizza there. For our round pizza, it's a 24-inch diameter, and the area of a circle is pi times radius squared. So my radius would be 12. So I've got pi times 12 squared, which is 144 pi. Well, that's not really particularly significant when comparing it to 440. So I can do 144 times pi is equal to 452.4 inches squared. Now that may not seem significant. Seems significant, 12 inches squared, but that's a that's a 6-inch by 2-inch piece of pizza. Like that's like this big, right? That's a whole nother piece of pizza. That's significant to me. Okay, so by finding out which one offers the most pizza for the money, you can figure out which one is the better deal. Okay, which brings us to graphical models. It's a visible representation of a numerical model or an algebraic model that gives insight into the relationships between variable quantities. Okay, so what we're looking at is how does a chart or our actual information compare to our graph? And so we're going to do a couple questions related to our graphs. So this one says match the numerical model to the corresponding graphical model and algebraic models. Okay, so we're actually not going to do the algebraic part just yet, but we're going to match a numerical, that's this one, okay, to our graphical, that's this one. A couple different ways to do this. Obviously, we're plotting points. Well, if these are negative 10 by 90, so this is my x and this is my y, I've got negative 10 to 90 and negative 10 to 90. You can sit there and plot every point, or let's look for a trend. In general, so as x increases, y increases. Okay, so they're both increasing. So if you see that x is increasing and y is increasing, that'll work. Well, are there any of these graphs that do not show x increasing and y increasing? So as x goes to the right, y goes up. As x goes to the right, y goes down. So we can immediately eliminate this one because y is decreasing. This is just looking at this, just a strategy for looking at these graphs. Okay? X is increasing, y is increasing, x is increasing, y is increasing. Okay. X is increasing quickly. And y is increasing slowly. Okay, so x is increasing quickly, y is increasing slowly. Okay, so our first point would be 10 comma 3, right? So at x equals 10, so if this is negative 10 by 90, so this is like 10 here. So at our first point, 10 it should be equal to 3. Y should be equal to 3. This could be 10, 3. This could be 10, 3. This is not 10, 3. So A is out. And so let's look at our next point. So then we'd have 26, comma 5. Okay, so the next one is 26, 5 at 26. This one's way up here. We'll check it out. If this is negative 10 by 90, then this is 10, 20, 20. So D is out because it's 26, almost 20. And so C has to be our answer. Okay, so how do we do that? Well, we eliminated obvious choices by looking at the trend in the data. Is it increasing or decreasing? And then we picked out specific points to allow us to try to figure out which one was which. All right, let's do another one. So this is the one we just did, except now we're adding the algebraic model. Okay, so we ascertained that it was C. We figured that out. Which is the algebraic model? Well, what do we do with that? If it's given multiple choice, all we have to do is figure out, when I plug the point in, does it work? So if x is 10 and y is 3, does 3 equal the square root of 10 minus 1? Okay? And so 3 equals the square root of 9. Okay, so 3 equals 3. That seems to work. Is there a plus minus situation that we have to have? So let's say you get stuck. Let's say you're on the fence about this. Let's just look at the other models and see what happens. Does 3 equal the square root of 11? So 10 plus 1? Nope, not B. Does 3 equal 10 squared plus 1? No, doesn't equal. Does 3 equal 10 squared minus 1? No. Okay, so it has to be this one. So let's say you're unsure about the plus minus. Well, remember, the function, okay, the function is taking the square root. You're not taking the square root. So it's not like you have to account for both of them. And so as you look, you just pick, you plug, and you say, okay, this makes sense. This one is A. Let's look at a different type. This is a graphical representation of some data. The table below shows the percentage of male and female populations in a certain county employed in the workforce selected from 1959 to 2009. Model the data graphically with two scatter plots on the same graph, one showing the percentage of women employed and the other showing the same for men. Okay, so let's just look for a second here. Down at the bottom, these are the years. Okay, so years. Okay, and an important measure is the measure in time of years since 1970. So 1970, how many years, when it's 1970, how many years has it been since 1970? So 1970 equals 0, which would mean 1975, the years since 1970 would equal 5. And so if it helps you, you can put it like this. This is 0, 5, 10, 15, 20, 25, 30, 35, because that's the number of years since 1970. That's what corresponds on here. So this is not just years, this is years since 1970. Okay? And so if the males are in red and the females are in blue, let's just look. At year 0, okay, year 0, the women, the blue should be at 41.5. Well, is blue at 41.5 in this one? Nope. Is blue at 41.5 in this one? Nope. Is blue at 4? Wait a minute. Here they switched up the key. See there? So you got to be tricky when you're looking at these graphs. You got to check it out. So in this case, my females start at, or the females are red. Does the female population start at 41.5? That could be 41.5, right? Can this one be 41.5? No, that's 50, so this one's out. So simply, we didn't even have to look at the whole set of data. See, that's what sometimes people get confused. They think, oh, I got to take in all this data at one time. You don't have to take in all that data at one time. If you simply look at what's going on with the first point, you could sometimes eliminate these choices and figure out, does this make sense? Okay, so we ascertained that it was C there. Okay, and so if we look at this, what we're going to do is we're going to try to figure out The table shows a percentage of male and female populations in a certain county employed in the workforce in years since 1989. Model the data algebraically with linear equations in the form of y equals mx plus b. Use 1989 and 1995 to complete the slopes. What? Use the year as x and the employment data as y. Okay, so if I have y equals mx plus b, and this is my slope. Okay, slope is equal to my change in y over my change in x. Well, what did they say was x? The year is x, and the employment data as y. So here's what we're going to do. For the women, okay, I need to find m. So y equals mx plus b, and m is equal to, they told me that the year was x. And so on the bottom, my change in x is going to be equal to 1989 and 1995. So I'm going to do 1980. Sorry about that. I'm going to do 1989 and 1995. Well, I've got 1995 minus 1989. Okay, on top, and this is important here. I need the data in those years. Okay, and so one important consideration I need to make is just like in the last one. Check it out. Since 1989. Okay, so this is years since 1989, and so my change in my x, the year as x, I actually need to consider the fact that this is actually, so 1995 would be 6, 1999 would be 0, because it's years since. So on the bottom, I'm going to have 6 minus 0. And then on top, I need the data for the women. So 1995 was 55.5 and 33.8. So up here, I'm going to have 55.5 minus 33.8. And so when I figure that out, I've got 55, 21.7 over 6 is equal to 3.62. Okay, 3.62. So let's see. That's my slope. And so if I'm trying to figure out y equals mx plus b, I need to plug in a point, right? So if I can plug in a point, that's going to give me my extra y and my extra x. And so I'm going to use 1989 because at 1989, x equals 0, because that's the year since 1989. So here's what I'm going to do. Y equals mx plus b. So y is my employment data, so 33.8 equals 3.62 times 0 plus b. Okay, so that would mean that b is equal to 33.8. And so my equation is, let me grab a red here, y equals 3.62 times x plus 33.8. Okay, so found my slope using my data, change in y over change in x, plugged in a point to figure out my y-intercept, graph my, or calculated my equation. What about the men? Same deal here. With the men, I'm going to use the same thing. So for the men, I'm going to do my change in y over my change in x. On the bottom, it's going to be 6 minus 0 because I'm going to use 1995 and 1989. So I'm going to have 62.5 minus 84.2. So I'm going to have on top minus 21.7. And on the bottom, I'm going to have 6. And so that's negative 3.62. And so when I figure out my b, so I'm going to do my 1989 because that's 0. So 84.2 equals negative 3.62 times 0 plus b. And so 84.2 equals b. And so my equation is y equals negative 3.62x plus 84.2. So you can see the trend in data is men, the employment rate's going down, and women, the employment rate's going up. That's a pretty good deal. Okay, last one. So that's a strategy for finding slope using data, finding an equation using data. An automobile rental company charges $39 per day plus $11 per mile for an automobile rental. Elaine rented a car for 1 day and drove 94 miles. How much did she pay? Okay, so if she rented it for 1 day, that's $39 plus 11 cents as a decimal times 94 is equal to $49.34. Beautiful. And Ramon paid $72.77 to rent a car for 1 day. How far did he drive? Well, in this case, we know what he paid, and it's equal to his cost per day, which is $39, plus 11 cents per some mileage that we don't know. Well, I can just subtract 39. So I've got 72.77 minus 39, 33.77, and I'm going to say it's equal to 0.11x divided by 0.11, divided by 0.11. 307 miles is what he drove. Okay, just some strategies for solving problems. Try to use those things to tie together data on graphs and to look at exactly what we're talking about in a graph and matching it up with equations. Or you can take the data and make an equation, or you can take some information, make an equation, and solve some problems with it. Okay, I know this can be kind of challenging because problem solving has a lot of different elements. But if you guys have any questions, please feel free to contact me. And thanks for watching. We'll see you next time.